ready.
Okay. Alright. Hi, my name is Marroquin. I'm a senior hydraulic engineer with BLACOH Surge Controls. We have our surge demo test stand here today at the Texas Pump Symposium. And in this test stand, we're going to simulate what water hammer is, how to see it, and how to mitigate it. So I have got about 200 feet of tubing wrapped around this vessel, and it's drawing water out of this drum, and it's pumping, it's going this way. And on the suction side, or the discharge of the pump, it's about 45 psi, and it's going to atmosphere on the discharge side. And what I'm going to do is I'm going to close some valves, and I'm going to close them really quickly. On this side, I'm going to close in the valve, and this dial is going to measure the pressure upstream of the valve, and you're going to see this thing spike up really high, and it's really quick, and you're going to see this thing shake. That's the funnest part about this, and I'm going to do that without protection, so you can see the effect of it, and then I'll do it with protection. So we'll start with that. I'm going to close it real quick and watch this gauge and watch how it shakes. Okay. So you saw a lot of things shake. In fact, we've had this test stand at a lot of sites, and it's really easy to break stuff even in our test stand because we're trying to demonstrate it without protection. Now the way to protect that is you need something to dampen that energy. So that energy is coming backwards from the valve and it's going up and it needs somewhere to go. And so like an airbag would dampen your energy if your face were to slam into your car, this is what this is going to do. And so in here is a Teflon bladder or a urethane bladder, depending on your application, and it has a pre-charge. And the pre-charge at the sides of this is designed to where that energy will go up into here, and it will accept that energy, and it comes back out much happier and calmer. So let's turn this on. There we go. And I'm going to do that same test, and you're going to see it's not as exciting, which is good. So the fluid went into there, but the shock wave that was in it was accepted by this here. Now, it's great to see this here, but this is not accurate. So the only way to see a water hammer event, because you have a sound wave going through there, is with something called transient monitoring. And BLACOH has a transient monitoring device here. This is detecting pressure at 200 times per second, and when it senses that there is an issue, the pressure has changed suddenly, it will begin recording at 100 times per second. This is important because even if you had a system that was capturing pressure at 1 ton per second, it's going to give you this graph kind of like this. In reality, when you have a true pressure recording, that pressure is doing many more fluctuations, it's much more dramatic. It's telling a truer story of what's going on. So that's critical to having that as a diagnostic tool, as a verification tool. Now, a lot of people are familiar with water hammer from a high pressure event. They've seen things shake, and it's assumed that it is a high pressure. It also happens as a low pressure event. And that's what I'm going to demonstrate here. So if I'm moving fluid and all of a sudden I let go or I stop moving or my pump loses power, that fluid's going to continue on down the line because it has momentum. Well, right at the pump, what's happening is the pressure is dropping suddenly, and it's causing a vacuum in that pipeline. And that shock wave's going to go out, and then it's going to come back and it's going to collapse that pocket, and then is where you see the shaking. The problem is that was a low pressure event, and you can't properly mitigate a low pressure event by solving for high pressure. In this stage, you need a BLACOH surge vessel to give energy into the system so that you don't develop that vacuum pocket. So what you're going to see here, I have the BLACOH surge vessel off, and I'm going to shut this valve, and my fluid's going to continue moving forward, and you're going to see this go to a negative pressure. Now you'll see it drop down dramatically on the gauge, and if you look at the cloud-based data here from the transient monitoring system, it will show you that the pressure is dropping to minus 10 psi. So let's see that. Okay, so I went to drop down to a vacuum minus 10 for my transient monitoring, and now I need to understand I got to fix this. And so with the right tools, the right understanding, and the right software to model an issue like this, like Applied Flow Technology is a great one. You can size your system and understand what's happening, which is key. and then properly provide a solution for that. And so when you have a surge vessel designed to give energy, and I turn that on, there we go, you're gonna see it's gonna drop down, but it's gonna be much less dramatic because it's protected. You see, it was a much lower, a much gradual, and it allowed that shock wave, low pressure shock wave to be dampened, and then it comes out and it comes back, and you have much less drama associated with the system. So, all in all, it's important to first understand water hammer. It's important to have the right tools to do that. Applied Flow Technology is a great software to do that. And then you've got to understand, okay, how can I have a robust way of mitigating that pressure, like BLACOH Surge vessels and surge monitoring, that kind of thing. So, hope that gives you a good understanding today. Thank you.